We continue review Math 1324. We have exponential equation here. So exponential equation where we have variable on the exponents. So in that case, there are two types. One, we can convert them to the same basis, or we cannot. The first type is where we can convert to similar basis. So for 16 is 4 square. So the bases are the same, so exponent will be the same. And we just solve for x. And now we solve for x. Right, just that. Of course, we don't have to use base 4. If we want to, we can just use base 2. So 4 is 2 square. And 16 is 2 to the 4th. Power to another power exponent. So we multiply the exponent 2 times 2x minus 7. 2 to the 4. And now 2 and 2, the bases are the same. The exponent will be the same. And the rest will give you 3, just like that. For this equation, we cannot change them into the same basis. So we can take the log on both sides, the log of any base. I will use log base 10. I'm sorry, log base e, or the natural log. So we move the x plus 8 in front. Now to get x by itself, we can multiply them out, get x by itself. Or here we just divide by ln of 4 on both sides. X plus 8 equal to ln of 7 over ln of 4 and minus 8 on both sides. So x equal to ln of 7 over ln of 4 minus 8. Right. Of course, the reason we take ln on both sides, we take advantage of these properties. In general, if I block a piece of something, we can bring the exponent the power outside. That's what we have. Now, so that's the answer. Alternatively, this is what we can also do. We take log base 4 on both sides. And log base 4 of 4 to the x plus 8, base 4 cancel out. We have x plus 8 equal log base 4 of 7 and minus 8 on both sides. We have x equal to log base 4 of 7 minus 8. And of course there's a formula that link log base 4 of 7 is equal to ln of 7 over ln of 4. So first, or log base 10 of 7 over log base 10 of 4. So like that. So on the calculator, either we use ln of 7 divided by ln of 4, and then minus 8. Or we use math, go down to option number, option B, option A, log base. Log base 4 of 7, and that's the same thing. Right, next, for the logarithmic equation, it could be more complicated than this, but it breaks down to two types. If we have a log on both sides, we cancel the log. This, we have a log and a number. All we do is we swap to exponential form. Base of 3, and swapping the 2 and x plus 1. And that will be 3 squared is 9, equal to x plus 1. Of h equal to x. Right. Now, one thing we have to worry about is for the log, whatever we substitute in here, it have to be positive. So we just have to check. Now we have at x equal to 8. Log base 3 of 8 plus 1 equal to 2. All we need to check for is make sure that inside of the log, the argument of the log must be positive. This is positive, so that's good. And 8 is our answer. Next we have this simple interest for the formula. Pretty much we have everything already except for R. So usually when we see this problem, there are two ways to approach it. One is we solve for the formula and then substitute the numbers, or later on we can just substitute the numbers and then find what is missing. So if we're looking for R, so if we look for R, we have to divide something that is not it, not R, meaning P and T. So we have R is equal to I over PT. Interest is 105. P 3000. Right. The only thing we need to worry about is the time is 90 days. Usually we should not use 360 days in a year, even though that's nice and all, but if we use that, we're missing a little interest. The 360 days a year is not a very good practice. In that case, a small amount of money is fine, but for the very big investment or that, we should not use 360, use exact 365 will be better, right? So 9 over 6, 360 is 1 over 4, or year, or 0.25 year. So we have that 105 divided by 3000 times 0.25. And we have that 14 or 14%. Or of course we can just substitute in the number and then find what is missing. 105 3000, or T is 0.25. First I multiply these two numbers together. That's 750, and divide by 750 on both sides. Like the same thing. So either way works. Right, so that's what we have. Right. Next, also we have accumulated values or the future values. Is that so pretty straightforward. Except this time we have the 10 months. One year is 12 months. Okay, so out the months. 10 divided by 12, 5 or 6. So don't use the 10 over 12, sorry. Yeah, so don't use a decimal like that. Just give the fraction. So hit math, change the fraction to just hit enter 1, 2. So 5 or 6 years. Always use the more accurate number. Exact will be the best. 7,996. 1 plus the rate in decimal. 5 over 6. Seven nine nine six times 1 plus 0.06 times fraction 5 over 6. We have 8,395.80. Right, times 10. Next, Alan borrowed 6,300 from his father to buy a car. We pay in 9 months. With that interest, find the total amount he will pay. So the 6,300 is that where he borrowed now. So that's the principal. And we paid after 9 months. One year is 12 months. And 9 divided by 12 is 0.75 year. With the interest 7%. And that is the simple interest because that classifying the same thing. The question is asked what is the accumulated values or the future values, because as for the total repay, so he borrowed 6,300, he need to pay a little more than that. That comes from the interest. 6630.75. Right, we just that. Right. The next three problem is compound interest. We're just going to use that formula. Or those two. Right, so let's write down what we have and what we're trying to find. Find the future values, accumulated values, so find A. So all of them asking for A. So straightforward then. Investment of 1500. Compounded quarterly 10%. Quarterly 4 times a year for 2 years. So the formula for compound interest will be just that. 1500 1 plus 0.1 over m is 4 over 4 times 2. I should just type 8 here. Right, 18. This one is just straightforward form. We don't even bother to use a calculator to find that, even though we can still use the app. So in this case, we said that n 4 times a year for 2 years, so that would be 8. Interest 10%. Present values we have none. Our present value actually we have investment, so that is out of our pocket. Don't make any payment. Future values is what we're trying to find, and will be 4 times a year, right? And now we find the future values alpha and yeah, so that certainly works. But like I said, I don't recommend doing all that. It's just straightforward. Right, next we have this one, investment of 5,000. Uh, 5%. Compounded monthly for 8 years. So 5,000. 1 plus the rate over 12 times 12 times 8. So 5,000 times 1 plus 0.05 divided by 12 to the power of 12 times 8. That much. Right. This one we still can use the calculator, but that should be simple enough. Next, I'll find the accumulated values. If it is continuously, then we cannot use the calculator. Right. So investment of 3,000. So once again, that's the principal. 7%. Continuously for 6 years. So continuously compound interest, we use this formula. Right. T. For 565.88. Right. So continuous compound interest. We have to use that formula. Very straightforward. Right. Cindy will require that much in 2 years. So she will need that in 2 years. How much money should she ask her parents now? So what she needs is the principal now. So we try to find out if she invests at 12% compounded continuously. So still continuously compound interest. So require that in 2 years. So once the future value is 13,000 in 2 years. How much money could ask if she invests 12% compounded continuously? And how much should she invest now? So the question asks for the principal. So A. Don't know P. E we do know. 0.12. T is 2 years. We will calculate all of this first. Second, ln. Times P. I'll just divide 13,000 into that. So that much. Oh, round to the nearest dollar. Sorry, didn't see that. So that much. Of course, we can solve for the formula first. That's the answer, by the way. If we want to solve for P, just divide by RT on both sides. E to the RT. So P equal to A E to the RT. Right. Right. How long will it take for 1400 to grow into that? If the interest rate is 10.2% compounded continuously. So the years are rounded to the nearest hundreds. Right. So we take, so this roll into that big amount. So we have the investment of 1400 and to grow to 39,800 at the rate 10.2%. If the interest is compounded continuously. And the question is how long, so certainly it's asking for time. Right. If it's continuously compound interest, we cannot use the calculator apps, so we won't be able to use the app here to find time. So we just have to do that by hand because the formula is this simple, and I still missed it. Right, that simple. Sorry. Right. So first we get exponential by itself by divide by 1400 on both sides. And to solve for the exponential, we'll take ln on both sides. And ln of a is equal to 1. So in that case, to solve for t, divide 0.102 on both sides. Right, we have 32.81 years, 82 years, up to the 100th. Right, so that's what we have. Annual percentage yield will be that one. 5%, semi-annually, meaning m is 2. I something up. Sorry, that's the plus. Right. So 0.050625 resume to the nearest 100 upper percent. So that's 5.06%. Right. Next we have the future values, and so this part we can either use the formula or we're going to use the app on the calculator. I'm going to do both. So if we're going to use the calculator, the formula, future values equal to the payment 1 plus I to the n minus 1 over I. So in this case, this formula we have, I'm going to use the calculator over here. We have n and I. So just going to substitute in directly. Actually, on this one, we won't be able to use the calculator. In the calculator, we have to, there are a lot more work if we use the calculator here. Because in the calculator, the apps will require to have, I don't know how many times it is compounded a year. In this case, we don't. So we won't be able to do that. Just by hand on this one then. 1,000. 1 plus the interest to the n of 13 minus 1. And 16,626. Even though it said 3 decimal places, but I prefer to just keep 2 because this is in terms of money. It to the pennies would be more suitable. Right, like I said, if we don't know m, it's difficult to use the apps on the calculator. Now, what is the future values? So once again, ask for the future values. Right, the end of 3 years. $200 is deposit each quarter. Payment is 200 each quarter, meaning quarterly, 4 times a year. Compounded 6% is compound quarterly, 6%, 0.06. Right. We need to find n and we need to find r. N is equal to m times t. How many times it is compounded a year times how many years. So in this case, 3 years, 4 times a year. 4 times a year times 3 years, 12. And then r is, I is equal r over m. The rate 0.06 divided by m for 0.015. So we have 200 1 plus 0.015 to the 12 minus 1 times 1 plus 0.015 to the 12 minus 1 over 0.015. Right, so that's how we use the formula. Now if we use the app, let's see what we have on the app. Enter again. So we have n equal to percent present value, payment, future values, period per year, continuously compounded period per year. Right, n here is the same as n here, 4 times a year for 3 years. Percent. This I is not this I. This I on the F is just whatever the rate is. You enter 6, not 6%. Right. Present values, we have none. The three things in the middle here, 1 positive, 1 negative, and 1 0. This case the present value is 0. The payment is whatever we make, so out of our pocket, so we have negative because that's what we make out, give out from our pocket. Present values, future values, we don't know. We can put anything there, and then after that we will hit alpha and enter, but not after we say this is quarterly, so it's 4 times a year. Right, so 12 times 6%, that's 0. Payment of 200, so out of our pocket negative. I just leave that blank or just give it 0 here, 4 times a year, so it's good. Now go back to future values, hit alpha, enter. Of course we should get the same thing. If 300,000 to be self over 25 years, so to be self, so we don't have that yet, so that is the future values. Over 25 years. We deposit monthly. Over here we use the calculator. Investment earn 8% interest. How much should be deposited monthly? So asking for the payment. So, of course, we can solve for that. Payment will be multiplied by reciprocal. So we're going to flip this on the other side. That's why we have this formula. Here we don't have I, we don't have n. I is equal to m times t. I'm sorry, n is equal to m times t, 12 times a year for 25 years. That's 300. And I is equal R divided by M. The rate 8% divided by 12. I'm just going to leave it like that because that is going to be a decimal. So I'm just going to leave it like that. So with that we have 315.45 cents. And now if we use the F on the calculator, N I percent present values, payment, future values, and how big payment a year. Right, so we just said 12 times 25, so that's 300. 8%, use 8. Present values, there's none. Payment, we don't know. I'll leave it blank for now. Come back and solve later. Future values, 300,000. Monthly, 12 times a year. So 300, 8%, 0. Just leave that blank. In the future we have 300,000, 12 times a year. I'm just going to leave that here, doesn't matter, because we hit alpha and enter, it will calculate the right number. So whenever we solve for, we just leave it as is, go back and alpha enter to solve for it. Right, you can afford monthly payment of that. Compound monthly, how many months until you have that much to buy a car. Right, so usually if the question in this type of problem, annuity, present value, future values, and other things, if we ask to find how long, or we ask for the interest rate, so pretty much if we ask for the interest rate or the time, then we just have to use the app. Won't be able to. It's more complicated, much more complicated to do this by hand. Right, so let's just say in this case, monthly deposit of 200. So the payment will be 200. It will be negative 200 when we enter in the calculator. Paid rate 8%. How many months until you have that much? So asking for time, or asking for n, how many you have until we have this much. And this one compounded monthly. Of course. So and we don't know. So in that case, just leave 0, enter 0 or whatever it is. We'll go back and show for that. 8% present values, we have none. Payment, we're going to use negative 200 because that out of our pocket. Future values 15,000. Monthly 12 times a month. Go back and show for it. So alpha, enter here. Leave 300 as 5, 8% present values. The payment is negative 200. Future values 15,000. 12 times up, yeah, that's good. Now we solve for that. Have 61 point something. So 61 point, this is monthly, so 61.0102 months. But for this type of problem, it's always have to round up, always round up. So to the 62 months, because we will pay 61 payment of 200, and on the 62nd month we have to pay a few dollars just to make up for that. So it's always round up, right? You deposit that much each month into account that pay 5.5% compounded monthly. How much interest will be? Right, this one a little bit different. As for the interest, so in that case we have to know what we make in the what we have in the future, and then we subtract what we have, what comes from all the payments. So let's say the payment 130. Into the account that pay 5.5% compounded monthly. Monthly. After 8 years. I'm using a calculator here. Alright. So we have to figure out what the future value will be, and that we subtract all the payments. So the future values is equal to payment times 1 plus I to the n minus 1 over I. Payment is 130. 1 plus I. Well, we don't know I yet. It's R over M. I'm just going to leave it at that. And N is equal to MT. $96. Sorry. 130 times a fraction. And we have that much. So So that is the future values. So we have the future value of this much. We make 96 payments, and each payment is 130. So we have 130 12 times a year for 8 years. We have that much. So just take this number, subtract that number. So that much. Right. If we use a calculator to find the payment, and % present value, payment, future values. Right, and 12 times, I'm sorry, hit the F's first. 12 times a year. For 8 years. Interest rate 5.5. Present values, don't know. Actually we don't have it. Payment 130. Future value we will show for that, so just leave whatever it is, doesn't matter. And 12 times a year, monthly, so that's good. Alpha and I should have that. If we want to solve for the interest, we just keep it at this, and we subtract 96 payment of 130 each, and we do have that. Right, so this calculator just help us to solve it. Let me write this: 96 payment, 5.5, 0, negative 130, and now we solve for that. Right, so that's what we have. Now, find the mixing, find the present values. Well, we have this. So the present values is payment times 1 minus 1 plus I to negative n over I. Of course, we will use the calculator too. $100. $1,960.04. Oh, 4 decimal places. I don't know why they do that. Not very practical. Right. If we use the calculator, Okay. Once again, it's just like the last one. We don't know this, so we can use the calculator. Yeah, there's a way to work around that, but not very helpful. So I'm not going to use that. The formula is very straightforward. Timestamp. How much money must be deposited now at 6% interest compounded quarterly in order to be able to withdraw 6,000 at the end of each quarter for 5 years. So here's the thing: we need to calculate how much a big amount of money put in the bank, and so that at the end of each quarter we can withdraw $6,000 each. So we have this at the end of each quarter. So that means the payment into our pocket 6,000. That could be positive in the calculator. 6% interest. For 5 years. How much we must deposit now? So that screaming present values. Alright, so present values, payment 1 minus 1 plus I to the negative n over I. We have 6,000. 1 minus 1 plus the interest rate. Now this is quarterly. 4 times a year. So first I will write n is equal to mt 4 times a year for 5 years, so that's 20. And interest rate is R over M. 0.06 4 times a year. To negative 20 over 1.015. So I have that much. Of course that would be a lot of money, but consider this: we would be able to withdraw $6,000 the end of each quarter, so 4 times a year for 5 years. So within 5 years we withdraw that much money. We only need to deposit it this much now. Right. So what if we use the calculator? And percentage present values, payment, future values. Right. And will be 4 times a year for 5 years. Interest rate 6%. Use 6 present values. We don't know, but we will solve for that. Payment 600. So this is the payment to our pocket. So I'm going to leave positive. Nothing in the future. 4 times a year. because we have the same thing. Right. Next, you want to take our loan to buy a new car for which you need to finance for that much. So we need to borrow the bank that much. Your bank will give you the loan as 5% compounded monthly. You look at the budget and decide that you can afford to pay that much. How many years to the nearest tenth of a year must be taken to meet those conditions. So we need to buy the car for this much. So right now we need the present value of 24,614. Rate 5% compounded monthly, and that we can afford the payment of 239. How many years? Right, so how many years? Every time we ask for time or ask for the interest rate, we just use the app, because shown by hand will be a bit complicated. So and we don't know. They ask for how many years, right? Put something here. We show for later. Interest rate 5%, 12 times a year. Payment 239 out of our pocket. We really need to have 24,614 now. Nothing in the future. Sorry. I just leave whatever that is. But 5% interest rate, the present values of 24,614, payment of 239, future value 0 for 12 times a year. Alpha, and we have 134, and that's how many years. So we just go divide by 12. That gives us 11.2 years. So 134 something payments. Always round up, so 135 payments. Divide by 12. We have 11.2 years. Forgot to write the timestamp. Right. Now we have shown the system by elimination and then shown the system by addition. Actually, these two are the same. Elimination or addition are the same thing. We're trying to eliminate one variable and solve for the other. So we have two equations, 1 and 2. Right. So let's say if we want to eliminate x, one of them should be negative. If we try to eliminate y, we should find the least common denominator, least common multiple, and simplify them. So here, what I do is I try to eliminate x. So it would be nice if one of them is negative. So I multiply negative 1 on the top equation. And when we add side by side, that cancel out. And divide by negative 5 on both sides. We have y equal to negative 2. So when y equal to negative 2, we can substitute back into one of this and solve for x. So if we substitute y equal to negative 2 into equation number 1, so 2x minus 14 equal to 12. So 2x equal to 26, divide by 2 on both sides. X equal to 13, so we have 13 and minus 2. Addition method actually the same thing as elimination method. So right, this one we try to get to the same thing. Let's try to eliminate y. Actually, I just going to divide everything by 2 on the top equation. That would be actually the nicer thing to do. So in that case, we eliminate y. But if we want to eliminate y, try to get to the same coefficient. So if 4, so we'll try to get to the same thing. So multiply by 2, or the multiple, least common multiple is 4. So I multiply by 2, but even better, make one of them negative. So 6x plus 4y equal to 48. And 6x, we multiply by negative 2, right? So negative 12. X, negative 4y, negative 120. So that cancel out negative 6x, and that 120 and 48, 72. And then we divide by 6. Negative 72, sorry. And then divide by negative 6 on both sides. So x equal to 12. When x equal to 12, substitute back in 1 of x equal to 12. Substitute that into equation 1. 6 times 12 plus 4y is 48. 6 times 12 is 72. Minus 72 on both sides. So 4y equal to 72 minus 24, and divide by negative 4 on both sides. Y equal to negative 6. So if x equal to 12 and y equal to negative 6. Suppose that the supply and demand equation for logo sweatshirt in the particular week is this: supply and demand. Find the equilibrium. So simple enough. We just have the system of equation. So this we just use substitution. Since both of them equal to P, we make it equal each other. So we substitute this into P. move everything on one side. Give us 0.3q and move the number to the other side. That gives us 30 and divide by 0.3 on both sides. So if q is equal to 100. If q is 100, we substitute one of this to solve for p. So q equal to 100, and we sub into equation 1. So that gives us for 10, so that's just 45. So equilibrium price is 45, equilibrium quantity is 100. Right. Next, draw the romantic matrix. So that is extremely easy. We just pull all the coefficients together. That for x, this for y, and this for z. Yeah. So that the romantic matrix corresponds to that equation. And the other way around is when we have this, we write back the romantic matrix. So assume that x, y, z are variable. So here we have x, y, z variable. So in that case we have 9x plus 5y plus 9z equal to -2. Ax plus az equal to 4, and 7x plus 4y equal to 2. So that's system of equation. Right. So should be able to write the romantic matrix for the system and write the system from the romantic matrix. Right, the next two, let me try the timestamp first. Right, the next operation to perform to get to matrix to reduce to echelon form, not the diagonal form, which is even more precise. So we work from column. For each column, we get the 1 first and then get the 0. So we have 1 here is good, 0 is good. Now this has to be 0. Now just try to eliminate this based on the pivot 1 here. So in that case, we'll just copy it, don't do anything. Actually, we will do something to it, sorry. We'll try to eliminate this. So to get to the same number to eliminate, just try to eliminate. I would multiply by -2. So this becomes -2, -4, +6, and -2, so -6. So multiply everything by -2. When you add these two together, that gives you 0, 2, 11, -7. So what we're trying to do is, with the answer to this is, we will multiply -2 to the first row, add to row 2, add to row 3, and replace to row 3. So the answer, we will have this operation, and then the answer will be, this will be the new row 2. So the answer here will be the operation state. So we state the operation, which is that, and perform the operation. So this is the result. So this is our answer. Next. So we have this. What will be the next operation? So let's check. The first column we have 1, which is good. 0 is good. 0 good. So now we go to the second column. The second column we need to have the 1 first and then the 0. So this have to be the 1. So there are two options. We can divide everything by 2. So either the answer for this question is either multiply row 2 by 1/2, or we just swap row 1 and row 2 and row 3. When we swap, the 1 will be there. For each column we have to get 1 first and then get all the zeros. So I'm going to go with swapping the 2 rows. Zero, 1, 5, -1, and 0, 2, 6, and -4. Yeah, swap 2 rows and that. Or you can do this and cut everything in the second row in half. Next, ceramic workshop make serving bowls. So we have, let's say, use B for that. Platters, I just use P for that, and bread basket. Actually, let's just use S for this and use B for the bread basket. And a serving bowl take 3 hours to prepare, 2 hours to pan, and 8 hours to fry. A platter. Okay. So let's just summarize the information here. So we have 3 things. The question is, how many of each can be made? So we have the serving bowls. Let that be S. Platters. P. And bread basket. If the workshop have, so in that case, in order to make an object, it have to go through the process of to prepare, to paint, and to fire. So this will take 3 hours to prepare that serving bowl, 2 hours to pan, and 8 hours to fire. Platter 15 hours to prepare, 3 hours to pan, and 4 hours to fire. The bread basket 5 hours to prep, 13 hours to pan, 7 hours to prepare, to fry. And total we have 122 hours to prep, 60 hours for paint, and 102 to paint, to fire. So in that case, if there's S bowl, the total time to prepare for serving bowl is 3S. And so on. So we add all of this, we have 3S plus 15P plus 4B is 22, 122. 2S plus 3P plus 13B equal to 60. AS plus 4P That's 7b equal 102. 3 by 3, so I'm just going to do system of metric matrix. And just do reduce to echelon form. So second matrix, go to math, option reduce to echelon form, apply to the matrix. This matrix has 3 rows and 4 columns. So whenever you're in the matrix, don't hit enter, just use the arrows to maneuver inside the matrix. So in that case, we have 8 serving bowls, 6 platters, and 2 bread baskets. Right. With that, we conclude this review. Thank you for watching.